Hello, welcome back to yet another video. My mic keeps going like weird for some reason sometimes, so hopefully it doesn't do that this time. I don't know why it does it, but anyway, so the thing I wanted to do now was I think making the base object class inherit from the serializable interface is a terrible idea. I think it's a really bad idea. And I was also then thinking, you know what if we just didn't have an interface for the serializable stuff? What if instead we used like concepts to serialize stuff, and we just have a templated function called like serialize, which takes in a type, and it then just we have the concept check if that type supports serialization, if it supports like, you know, the stream output operator and you know, things like that. But obviously, what does it need to be able to be serialized? Well, it all boils down to just a serialized function where that function, where that object or that class overrides that serialized method or function. So what's the point in having a concept if you've just got like a single function that does it anyway? So I was kind of, you know, going through this thinking like, you know, lots of different concepts of things, and it's like, if we just have a function that does this with like, you know, this concept, then like there's not much point in having this as an external function. Just call the deserialized method on the object itself. Right, what's the point in having this function? But then I was thinking, you know what, we could have a reason to use the concept, which is if we have an object and we can say that any object that supports the OStream like out operator, any object that supports that can be serialized. That would make a lot of sense, or like, you know, that kind of thing. But how would you serialize to JSON at that point? It doesn't really make a lot of sense. So unless I can make it make sense, I'm just going to have anything that can be serialized will just inherit from the interface, but objects by default won't. So entities will, but anything else you've got to manually inherit from the interface yourself. And that means that the serializable registry is not going to have the base class of serializable. It's instead going to return a void pointer. So we're going to create the actual object of the correct type, but we're also going to just return it as a void pointer, so that then when you get that object or like get that pointer, you should then know what to cast it to based on whatever the name is. And so, for example, when we have like the function for new object, wherever that is, when we have this function, because it would be a void pointer instead of a serializable, we would do a static cast to object, and then that should just work fine. Obviously it might not, because it might not be the right type or whatever, but for the most part you should just know that the type of this is, you know, supports being cast to an object because it derives from it or something like that, right? So yeah, so I basically just want to rewrite the registry again, because I don't like the idea of objects just inheriting from serializable. I think it's really dumb. Let's get rid of that. Let us get rid of this unique pointer thing as well. Let's just simply have, I'm not even going to have this. I don't think we even need these. It's going to be super simple. Yeah, like super simple. So this object now is just its own thing. I also want to quickly, I keep forgetting about this, but I do want to do this. I want to have this be an enum class outside of the object itself. There we go. And obviously this is, we can do like some kind of like implicit thing, can't we? Yeah, no, we can say using object flags or something, I think. Or something like that. I think we can do something like that with the enum classes, but for now at least we need to cast. Like that, and then obviously these are going to need to be changed. You know, maybe it's not a good idea to have it be a scoped enum. I'll leave it as unscoped inside of the object here for now. I could just call it flags actually instead of object flags. Yeah, for now, yeah. I'll just leave it for now. So the serializable, this is not going to be in this header. It's going to be in a different header. And this serializable private thing, I think everything's just going to be in this one file. So we're not going to have this private thing anymore. So that means we need to do a little bit of a move around, where we take this private, we rename this file to just like class registry or something, and we can just move it out into here, and then in our serializable thing we can just take this out completely, get rid of that. And then in our class registry, put it at the bottom here. Okay. So we then want to get rid of this private folder, and in our CMake lists we want to add class registry. There are other things I want to do as well, but this is just the first one. So, oh yeah, add subdirectory. Need to change that as well, because this, there you go, that shouldn't exist. Lovely. So now we have our serializable, which should be completely fine on its own. I don't think we need the class name or anything. I also want to change this to a non-const reference. Just have it return void. That means we can do the forwarding header instead, which means we don't actually include all of the JSON library, we just include the forward declarations of it, which is a lot better. It'll break a lot of things, but don't really care at the moment. So we also now want the class registry header. Everything will be in this registry. We can make everything void pointers now. And we're going to change this to class registry instead. Yeah, register class is all good. This is just saying it's not used, which is fine. So we can just call this class registration instead. Sure, registry entry is fine. Okay, so we have, let's just look through this again. We have create object func returns a void pointer, serializable map with this and a string. We could make this an int and do some hash, but that can be done later. This is not used, okay, whatever. Then we have create objects. This will be a private one, so we can, yeah, I'm thinking, what would I name it? I also want to have some kind of concept, I think, for this, where we just specify if it's a class or not. I also do want some kind of like idea of like my own concept library. So like having a concept.hpp or something in the Tails engine, just for like, you know, general purpose concepts purely related to the Tails engine. I think I made a note of a few of them. Yeah, things like printable, user type, derives object, derives entity, that kind of thing. This can be, you know, I'll leave this as, actually no, I should keep it user type, because then it makes more sense using it here, because we're saying this is a user type versus this should be a class, which would make more sense as it requires, like here instead. Because then you're checking, is this a class versus this is a class kind of thing. I don't know. But anyway, we can have this as user type, which then just essentially expands out to is class V, which is nice. And this will work for structs as well, I'm pretty sure. Yeah, so we just want to make sure that the thing that we're taking in is indeed a user type, a class or a structure. We could, instead of doing this here, we could have it in here, which might make more sense. Because then if we're doing it in here, that leaves us open to be able to do anything with this if we're not using this macro. So I think I will do it in here. And then just have a normal type name in here. Obviously this will have the things we'll need to say, like, you know, Tails : or whatever. This will be put in another concept header. Let's make that header actually right now, just so I don't forget, so I can compile and stuff. Concepts. I don't know if we need to prefix it with anything, but we can make a note of that if we need to. So we can just say concepts. And then do another build. So then we can say make a template. This first one will just be if it's a user class or not. So obviously we need to include type traits here. And then here we can include the concepts. This might then show that it's in use. I don't actually know. This might just be saying that it's not included anywhere, or it might just be, I'm not exactly sure what this means where this macro is not in use. No, it would be if it's included twice. Because now this is saying, yeah, this is going to be in use after it's been defined. Maybe it's still in use here. I don't know. But yeah, so now we can check for if it's a user type or not. So that's good. I might call this create object implementation as well. Okay, so this is all in the header, obviously. I don't think it needs to be outside the header. Yeah, no, it doesn't. Apart from maybe debug, because debug is only being used in here. So if there's, actually no, this is templated, so it has to be in the header anyway. There you go, this. Okay, so that's that. We have a concepts kind of header now as well, which I'm going to add a few more to, just because might as well. We have, if it's printable or not, let's put this over here. The printable things will be if for like formatting, printing, and, well, not formatting, but for like the general print debug thing. You can see that in here it just does this, so it won't work on types that don't implement or override or overload this operator. So we want to check that it overloads that operator before, saying that we can print it. So we can say just printable. And we want to require an instance of the T objects and then the OStream to test against it. And we just want to say if we can pipe object into stream, and that does return an OStream object. This is not even called stream. Here we go. Yeah, so if we do implement this, yeah, so if this can function, if this is allowed, if this can happen, and the return of this is this, then we are allowed to use that type in the template. So then we can specify another one for the arguments, because obviously this is using with variadic arguments. So we want to be able to do that. So we can simply just say like printable all or something, which we then just want to check if each argument is printable, and just do it for all of them. So we can make a note of these. Checks if a type can be printed via streams. Obviously, we might want to call this like stream printable or something instead. Or like printable stream versus like printable string or something. Just because then if we do have another one which is called printable, that can be like printable string or something, where it has a toString method or some kind of implicit conversion to string. And then we can, let's try and do some weird preprocessor magic. Let's include the concepts if no debug is not defined. So let's just say if we have tails debug defined. Then here we can also say if tails debug is defined, else like this. So if debug is defined, we want to use the concepts principal stream all, but if it's not, then we just do the normal one, just so that it still compiles, because we still want to have this function be visible even when it's even when we're in release, because otherwise it might, otherwise we just want to use a macro for that, but it's gonna look really bad. But it's not that bad. So tails debug is that, then we can do else this, then and if and here can be the principal stream all. Okay, so that's good, because we only call this operator if we're in debug anyway. So this print is just an empty function when it's in release, so it doesn't matter. So if we're in debug, we include it, and we change the templates to whatever. If we're not in debug, then it doesn't matter. We could probably actually change this to something like I don't know if this would work. But if we did this, for example, where we we do some weird thing where we only change the type name to this, so yeah, so yeah, so we have to type the template. What's in the template is just dependent on if we're debug or not, and then yeah, so that's, it looks really weird, but it'll work, I think. So we can literally just copy this same thing over to here, and that should be fine. This looks so like cursed, but bear with me here. But yeah, there we go. Nice. So we have that stuff. Objects is fine. Yeah, obviously then we can create, you know, just general functions to do things. Because this class registry thing is just completely fine now, we can we can create just a normal public thing about just constructing any kind of object, right? Where this should be user type. We want to then return the T. We can say create objects, and we can take in a string view. Now we can get our registry. I want to call this something else as well. Get class registry, serializable map. Let's call it class registry map instead. And that's all good. Then go class registry, and then here. What if I did just indent this all again? Yeah. Okay, so then we can get the iterator, where we find the name. In here, obviously, there's no argument because we want to get the data instead. And then, because this data is a const pointer, and that's fine because I think this expects a constant. Yeah, that's fine. And then obviously we can say, you know, if the iterator is equal to the end of the map, then we like log it. We can say debug error. How to create objects. Name of type ID of T dot name. Name is standard, by the way. It's the raw pointer one that's, it's the raw name that's not. That's the MSVC one, I think. Because it is not registered. Nice, then we can return null pointer. So here we can simply just return a static cast 2t from the its, second calling that function. There we go. So now we have a simple generic, create object. I might call it like allocate object or something. But that means that in something like object here, we can just provide a function to create a specific object function, set its outer and stuff, and then return it. So this function would act like a base for all of the other functions that help you like allocate things. So obviously this is saying you're not including it, which is fair enough, because in the entity also saying you're not including it, we're also not actually overriding the interface here. So in the entity, instead of having the object, we just do that, and then we don't even need to return it. So that means that when we serialize, when we override this as like a child entity, we can just get this object, add stuff to it after, deserialize, once again, just get this object and take whatever we need to from it. Get level, cannot cast, we know about object. From C object const to C level. Expression type is not polymorphic. I don't know what that's on about. I'll fix it in time though, I'm sure it will be fine. So obviously we need to include the thing to be able to do stuff, so we can say class registry here. And now we're actually able to register the C entity class like so. Check if it's a user type, like if we just say int, then this is going to throw an error because int is not a user type. So that's nice. And then that also means that the player now works. That's good. Oh yeah, I did change this as well. I set MID to -1 just by default, because the default constructor would set it to 0, meaning it is localized, because it's only not localized if it's not. It's only not localized if it's less than 0. Also, these warnings of not forwarding the arguments, you can just do forward or whatever here, right? You could do that if you wanted to, but I did actually look in the standard source code for not for make format args, but for just the general format function, and you can see that this has the args as an R value, and it makes format args. This make format args takes in L value references, and it doesn't forward it. And this is exactly what I'm doing, is I'm taking in R value parameter packs and not forwarding it into a non-const L value reference input. So I'm going to keep it not forwarding, just because that seems to be what the standard does. Although, saying that, we do have, where is it? We do have this. This accepts a format string. I don't know if it accepts just a normal string though, because v format accepts a string view and format args. So if we can use format instead of v format, then we don't need to worry about forwarding and things like that. We can just do whatever the standard does in its implementation. So if I change this to just format, then I mean, it seems to work. And then we can forward it here instead. Because this just takes in the arguments straight up. So I think that should work. I think. I don't actually know, but I think. Because this string is just a string, so if I do that, I think I've yeah, I really don't know, but if I build it, obviously we're going to get a bunch of errors. This is saying return type shall not be show return instead of doing convertible to. Oh, interesting. A return type requirement shall not be a trailing return type. Does it have to be convertible to then? Instead of same as? Actually, it might just be because I'm not including OStream. Yeah, I'm going to have to include OStream, aren't I? Does this still make that error? No. Okay, so yeah, it was because I didn't include it. This is now obviously complaining because we don't actually need this. Yep. Yeah, in Loman, whatever. Lots of world stuff. Let's just rebuild it. More things, but with widgets this time, because we are not serializable here. Do I even have anything in these functions? No. Okay, I just won't make widgets. So yeah, I'm just going to ignore widgets for now. The engine serialize method just doesn't need to exist. And that should be fine. Then we have dynamic cast, not a polymorphic type. I don't know why. Oh wait, no, it's because I'm dumb. It's because object no longer has a virtual destructor. Because I deleted it because I made it inherit from from interactable. There you go. So those dynamic cast errors should be gone. We have serialize, which is not a member. Forgot to get rid of the world's implementation of it. We have level. The object of type is not a thing. Yep, that makes sense. I should probably make that function now then. But before that, let's rebuild it and see if that's the only things. We have serialize. We can get rid of this for the level. Level might need to be serialized and stuff, but that will be a different function from serialize. It would just be like load from file. It will be load from file or something instead. That's all fine. Now if we rebuild again, hopefully... Okay, this is the only error, that's good. So, in the object header, I want to... Yeah, we can just make a templated version, and we also want to... I'm going to make a concept for this quickly. Let's make it a user type as well. Actually, no, it will be a user type since it derives. So we can say concepts derives objects. Then say derived from. Derived will be T, base will be C object. And I think we need to forward declare it. Yeah, okay. So now here we can say if it derived. Obviously need to include the concepts. If it derives objects, then we can return the T, say just new objects, string view, and the object outer. So Yeah, I'm thinking we just have a non-templated one as well, which returns an object. Like this. This is going to be the actual implementation of it, meaning we only need to include this header in the object CPP file, so we can get the class registry, and then say create objects, C objects, the name will be this, and we can say, you know, also results going to be C objects. We can then just say result outer, it's going to be outer, and then return result. So this is where we do, like, you know, actual object specific setup stuff, and then in here we just convert that again to the specified type. We say return, we can do a dynamic cast 2t from new objects name and outer. Although actually it might be better to do a static cast here. I don't know. I tend to do a static cast with templates, just because it seems like it's the better idea. Because obviously you know that this is going to derive from object because you state it up here in the concept. So there's no fear of it failing, because if it's not deriving from it, it won't even get to that part in the first place because you have a concept on it. So it should be fine. So now in the level, we can, instead of doing new object of type, we just say new object and then specify the templated version of it. So now hopefully if we build, it should work, and again, even more hopefully, if we just do that, and then if we try and play it, it should still run fine. Lovely. I did change this to player 2, so if I move this back, then we should still get the texture loading, and okay, cool. So it still works and all that. That's good. That's good. So now it's a it's a much more generic class registry than just for serializable things, and that also means that currently only entities are serialized or can be serialized, which I think is a lot better than every single thing that derives from object being serialized, because you don't need them to be. You don't need the world to be serialized. You don't need the engine to be serialized. You don't need well, you might need the level to be serialized, but that would be like via a different way of doing it. So, you know, it's kind of it works for now at least. So the other things I was thinking of doing was, we've done the printable things. I was thinking of having a printf function in debug. Probably not going to use that as much, but it'd still be nice to have. So I want to go to debug here, and oh goodness me, this is going to be terrible if I just keep doing this like if stuff. We want to have another template here. We want to check if we're in debug or not. If we are in debug, we want to make sure that actually we don't care if they're printable or not, do we? We don't care if they're printable stream because we're doing formatting, and the format has their own concepts for it, so we can just do a type name. I just do that, and then we can say printf, and we can simply print a string view. Just call it string, and then our argst for the args, and then we can see out a format which we actually need to include. We can include it if it's in debug and stuff, so that's better. Like that, we can then say if tails debug. Yeah, I quite like preprocessor ifs and like directives and stuff. They're quite cool. Do an end line, and then in the format we have the format string and then the types. So I think we can just use string and then obviously forward the args into it as well. Or instead, just accept a format string. I don't know. I think this will be fine. This is never forwarded, even though it is forwarded, but that's fine. I also did want to do something else with something. I can't remember exactly what it is though. Okay, I want to have a look at the assert header as well, because this is a macro. I want to change this to tails assert, because it just makes more sense for a macro to do that. And also, I want to change this tails function thing from being a macro to just being a function. And we can do that by the namespace of tails, obviously. And I want to just provide different like helper functions for things. They're all going to be constant expression just because they kind of should be. So we want to get the file name, right? And these functions would just be able to be used to, get the current thing of things or get, a specific thing. So we do that with something called source location, which I do need to include, but we can do it if it's in debug or not. Actually, no, I don't even need to care if it's in debug or not. I can just include it straight up. Yeah, so source location, it doesn't matter if we're in debug or not. And we can set this to be the default, like, current thing. Here we can just return the location dot file name. And the thing with that is, it's passing my constant reference. Can I do that? Can I set itself a default thing here? I can. Because source location literally just stores the line, the column, the file, and the function. I don't know how big it is. 24, meaning it is bigger than a pointer, so we should pass it by reference. But yeah, basically, if we have it as a member of this function, then it will just return the file that this function's in, because we go into that function and then we're in that function when we get it, versus passing it in here. It means it just does it with wherever the function's called, because this is like implicitly done when you don't put anything in. So it's almost like a bit of a hack, but it's very useful. So now we can have basically just want to print out or like make helper functions for each of the kind of things that we can get. So for example, the function name as well. We can just return the lock dot function name, right? Stuff like that. So obviously it's very useful, and these are also constant expressions. So they're also no except. I should probably make these no except as well. This will then be a uint least 32 to get the line. There we go. So yeah, these are just kind of giving you they're just kind of giving you slightly like better than macros well, maybe not better, but I don't know. I feel like they're safer than macros anyway. And I think I kind of want to move away from macros as much as possible. So if I can use a function instead of a macro, like if I can use a constant expression function instead of a macro, then I want to. So then obviously it's no, I don't need to do this jargon anymore to get the right function like macro based on the compiler. I can just say in here tails get function name, right? Like that, and then instead of file, we just say tails get file name. Yeah, and then instead of line, we can do tails get line. Yeah, the only kind of reason why this isn't a constant expression function and why it's a macro is because I want to be able to print the actual text of what the condition is, because if not, then you're going to look at the assert and be like, okay, something failed, but I got to look into the source code as to why. Versus this, you can just see, okay, this was, an invalid thing or something, right? So that should help, because otherwise you could go and say assert or something, make your own assert function, have some kind of condition, or have it be some kind of like predicate. Right, and then like, I don't know, some kind of message or something, I don't know. And then you can say, if the predicate fails, right, I call it like a function, then you can, print whatever, and then like throw an exception or something. Because here this just aborts, which abort doesn't have any kind of things here. I suppose you could do something like, what was it called? Yeah, exit, because that has @exit as well. Yeah, so you could do exit and then specify, the error code of 5, right? And that will exit with the error code of 5. Obviously it's saying it's not thread safe or whatever, but yeah, at least this does work. If I can, I'll probably want to use a function instead, but the macro is fine for now, because you could say tails assert, and then you have a lambda in it which takes in 2 numbers or something. I can't remember exactly how that works, but you can say failed or something. I don't know. But yeah, so for now at least, I'm gonna just comment this out and just say like future possible assert function. Anyway, so that's that. Yeah, I don't actually know if there was anything else I wanted to do specifically. I do want to tackle like level loading and stuff at some point, but it's like such a big thing that I'm just not ready for that yet. But yeah, let's once again see if it builds, compiles, runs. Okay, sick. So that's good. I do just want to use the assert as well, just to make sure it does work. So for example, in the world or the level, let's say if we this, for example, we want to assert. We want to say if result, then result fail or something. I don't know. Obviously, it shouldn't or anything, because if this fails, then it asserts. So if we go back to the main and then force it so that we take a class name which actually doesn't exist, such as, C player 2, and then run it, what happens? We get a fail to create object C player 2 of type class C object because it is not registered. It's saying C object because and not C entity, because this just wraps this function which uses C object. So that kind of fails when you're wrapping stuff like that. Actually, wait, what am I? Why did I even? Oh, it was for this function. That's why, yeah, so I don't include this in every single thing that derives objects. That's why. Anyway, that's fine. So this is saying it's not registered. The error, meaning we should probably go in here and it's, where is it? First create object of type, because it is not registered. This then returns null pointer, which in here we try to access a null pointer. Here we can say if result doesn't exist, return null pointer, meaning that this then tries to cast from a null pointer. I don't know if that probably won't work, but then this is doing a thing. This is also saying, does this have a, it does, yeah, I don't even need a semicolon there. I think this will probably still, yeah, it will still have some kind of like segfault thing, but because obviously we're doing, yeah, we're casting here. So obviously we could just say if objects, get our new objects, name and outer, if it's valid, return the static cast from it. However, if it's not, then return null pointer. And then that might then allow that function to exit. Never mind. We have this, for some reason this is, what? I really want to get to the bottom of this for some reason. Obviously this doesn't have an out or anything, but it doesn't need to. Our flags is just, it's got one. The engine shouldn't be pending anything. I should probably change that. In the constructor we shouldn't be pending anything. Wait, can I not set pending? Wait. Oh, mark, that's why. Unmark for create. Engine should not be pending create. Bang. Anyway, let's go back and look through what's happening here. So the issue we have is this new object is, we have, this is the create object function apparently. I don't know assembly, so it's all kind of a bit jargon to me, but is this the entire function? Where we have we have this, which seems to be the null pointer. This is racks, and we're adding something to it. So obviously in main we have this, but inside of the new objects function, which is, we have our level, which goes into this new objects function. For some reason it's going to typed outer. There we go, new object. Something around there. So let's set a breakpoint. Set a breakpoint here as well. Let's just have a little look around. No breakpoints are being hit. Our name is cplayer2. The outer is the level. The result is null. Oh, maybe it's because we're putting null into a unique pointer. I'm so confused. Why is it not triggering any of the things? Because it's not registered, and then exception encountered at address access violation writing to location. So it's trying to write to a location where it doesn't have access to. So this is fine. We have our name. We go next, we find it. Our registry has entity and player. That's all good. We're trying to find player 2, which obviously doesn't exist, but we do have a function here which returns void. It points to this function, the one with cplayer. That's all good. That is very good. If we go on to the next one, we see that the size equals 2, and obviously this does point to end. That seems fine. We then return null pointer. Coming straight out of this, we should then get this, but we don't. We go back to main for some reason, and then into the disassembly here. So it can't fail gracefully, essentially. Meaning, I think we just assert it instead. Instead of doing this check, we just do a fat assert. We cannot create object. This its type is not registered. So now instead of having this error thing, we will have an assert. Never mind. What? Wait. Huh? What? I'm so confused with what's happening here. You know what? To do. Weird memory issues when something is not registered. Make it fail gracefully. We could just throw, I suppose. So runtime error saying essentially what this is saying. So now in whenever we call this create object function, we can do a try on it. Why does it keep? Why is this being called? Oh, you know what? I'm so stupid. It's because we aren't linking it. We aren't relinking it. So I'm just running the same thing over and over. Yeah, we have our exception going on. Oh, it even brings us to the file as well. Assertion failed. Lovely. So that means if we do this, and then we relink, okay, we still get an assertion, that's good. Because, except now it's this assertion that's failing. Result fail. I think we probably want to keep the assertion in here. Instead of just returning null pointer maybe. Or making it throw. I don't know. I'll just keep it as assert for now, just because, yeah, you know. Well, I think throwing is a better idea. We can throw a C exception. Say, fail to create objects. It is not registered. Its type is not. Its type is not registered. We throw it. There we go. So now in like here, for example, we can catch or try catch or something. Hang on, I forgot to relink it. Okay, the throw has happened, the exception has happened, and that's good. It doesn't actually tell you what the message is though, so we should probably keep the debug stuff in. And I also want to do this. So now if we run it, I've got to relink it first. This is the plight of my existence with this, is relinking this stuff. So yeah, so it crashes, but we do get a message here saying failed to create object of type class C objects with ID C player 2. So that's all good. You know what? I think I might just include this. It's not going to be that terrible if I include it, right? Just because I want to be able to get the actual type. Yeah, I'm gonna... Wouldn't be that bad, right? So obviously that does that. If it succeeds, then we want to also say objects outer equals to outer, and then we don't even need to static cast because we're doing that, so we can just return the object, and then obviously return null pointer, and then here we just wrap the other thing where we can just say return new object of name outer. Obviously this is going to be recursive, we don't want that, so we're going to call the templated one and just say object instead. So now in the level, when we... Where is the level? It's not even open anymore. Here we go. In the level, this we'll call this, which calls it straight into here, which gets the correct type, or should do anyway. So it'll still fail and stuff. Never mind. Oh yeah, obviously this doesn't have an outer. It doesn't have an outer, does it? Still need to relink, I think. Yep. But should work. Yeah, so now we're saying Z entity, because obviously in our level we have C entity here. Now we do have a templated one here which has a make unique. I'm actually going to make it use the new objects. And I also want to make an overload of this so that we can create an object without it being in the registry. Yeah, so we just say, also object is going to be equal to, new T object outer is going to equal to outer, and then return objects, pretty much. Can do other stuff in there as well, but there we go. So now it's using this, and then we can also make another spawn entity thing. Where we say spawn entity, but we want to give it a string view as well as all of these. And this will essentially just be the same as that. So yeah, pretty much just say return spawn entity implementation. We want to actually, yeah, this needs to be put in a unique pointer. This also needs to be put in a unique pointer. And we're going to say new objects, class name, this being the outer, we want the type to be this. And then we also want to put in this is part of the unique objects, we want to put in the position, rotation, and scale, I believe. Yeah. And then this, instead of doing this, we could probably just do, you know, return spawn entity of type C entity, put in the class name, the position, the rotation, and the scale, and do that. So now all we need to do is have our concepts. Yeah, I do have the concepts here, so we can. I'm going to include them anyway, actually. Doesn't hurt to, and I want to go to it as well and say derives entity. If it derives entity, this one will be derives entity as well. So we don't need to static assert it. And that's all good. So I should probably put a comment somewhere saying functions for creating children of C objects specifically. Function for creating any object registered in the class registry. We could construct class actually. That'd make much more sense. Class type, class class name, constructed class object. Then we can also have a a void pointer called it construct class. Just be the super generic one. Just copy this essentially. I don't really. Do I want to? I don't know, but we can just do that. Yeah, I think, actually no, I can just wrap this one with this, can't I? I think. We can just say, return this, but instead of it being it second, return construct class name. Yeah. Registered class name. Say constructs, or let's say allocates. Let's say constructs an object of the specified class name. And returns as void pointer. Constructs an object registered in the class registry. Cast it to the specified type. Okay. So now obviously this is going to need to change to construct class. This is obviously going to be at least an object because of the concepts. So I assume IntelliSense is, yeah, it gives me the stuff. So even though this is actually a void pointer, well, no, it's not a void pointer, but it doesn't know what type it is specifically because we don't have any specializations. But yeah, so now, you know, here it should just work just fine because this calls new objects, which obviously, you know, works fine. It's one entity from its class. Entity in question does not need to be registered in the class registry. However, this one it does. Initial position, initial rotation, initial scale, pointer to created to spawned entity. Spawns an entity from its class name and casts it to the specified type. Spawns an entity from its registered class name. This is what will be used in like going from like JSON and stuff because we don't want templates and stuff. This is why it's so important to have this registry so that we can literally just say spawn this class name and that's it. Yeah, that's why it's so important, I think. So anyway, that's that. I don't know what else. I want to try doing a printf, actually. Let's do it on the player. Let's printf every frame. No, let's not printf every frame. Let's printf here. Interesting. Which one of these uses debug then? Because I don't want to just have debug included everywhere. Resource manager, yeah, resource manager for this. Yeah, whatever. It's fine. So debug, we can print F here. We can say loaded player texture. Do that, and then we can say, you know, player.png, let's say, just to see if it works. Then we can play it. Okay, our basic format here, call to immediate function is not a constant expression. Which, sure, fair enough. Can I just make this a constant expression? I don't exactly know how constant expressions work, but that'd be brilliant if I could just make it a constant expression and it would just work. No, okay. It's fair enough. So, okay, why is it not evaluating to a constant expression? We have basic format string, which has character, and then this. Let's just have a little look. This goes to this, where we have a format string. We go into a V format, which has a string view, the args. We have a format 2, which then pass format string. So parsing it and stuff. I'm not seeing basic format string. Oh, okay. This is a basic string view. Okay, basic format string. Okay, so format string is a basic format string, meaning this is actually a basic format string of character specialization. So I think because of that, maybe it's because it's a string view that it's doing that. I don't know, I'm just spitballing ideas. No, so it's not a constant expression, which is very interesting. We could just use v format and not forward the arguments. That would work. We can instead just say make format args like that, and I think that would work. Oh yeah, cplayer2 isn't registered. I haven't actually changed that. Where's my main? Here we go. Go back to cplayer. There we go. So we have that, and I believe this is the thing. We have loaded player texture player.png. I believe that's the exact words that I used. Yeah, loaded player texture player.png. So there you go. The format stuff does work. We can do, you know, 1 and then 0, meaning, you know, we can say 50 here, and you know, we can do other stuff. We can like display the 50 as a what we do in a string. We can display the 50 as a like a hexadecimal value and stuff like that. So we have, you know, 32 because it's taken the number 50, putting it here because it's the 1 index, and then this one's going here because it's 0. That's kind of the whole thing with localization I was going on about last time. But yeah, we have a formatting printf now, which is good. Errors, we could probably do a formatted error as well. But yeah, I don't know. So the types coming in here, I don't really care what types they are because I'm passing them onto format, and format's the one that cares. And to be able to format like a class and stuff, you have to have like your own specific like formatter structure specialization. It's actually quite easy to make. So I could do that for the entity, and I can probably make some kind of like macro for it. So like at the end of your class, you say like register class, and then you also say, you know, make formatable or something. Right, like this or something. And then this would essentially just expand to it has to be std formatter. You know, but essentially expand to this with a pass function and, you know, whatever else, and it would just be a simple kind of thing. And then that's what the format function would use to know how to format it. I might do that some other time, but that's, you know, another thing. And then that could just be part of the register class as well. So, you know, any class that's registered also is able to be formatted. But yeah, so that's quite cool. I do also want to work out what I'm going to do with sound stuff, because I just don't know. But yeah, I think that'll be it for today. Thanks for watching again, and have fun.